then go down to commission. Everything. As configure additional platform din. Next. Next. Allow the modules to load. Let's fix graphics, fix HVAC, add all our PX graphics tools, and then we say next, next, and allow it to load to our station. Now we'll be ready to edit our graphics once we have all the necessary tools or module added. Okay, now we're back in our station. We'll start out by heading down to our points and our I/O module, and we'll start out by creating a PX view, and we'll attach it to our module. Or this is our I/O module, which serves a unit, so figure it may be our unit. So we'll right click and we'll have to views and scroll over to new views and say OK, and we will call this our unit. AC unit, and we say OK. Now here goes our PX view or our graphics. So just double click and edit the layout. Let's make it a little bit bigger for me at least. Whatever you like. Our programming. So after we create the view, which is our graphics, let's add all our kit pick tools. Added. And T. It picks graphics, make sure that's added. So now that we got our background set, we'll then grab a point and drop on our view, and it pulls up our widget here. So just go down to Kit Picks, and in Kit Picks module, set point field editor. That will wrap it nicely for you, and you drop it. There it goes. Just back up. You can take a better look at it. Now, when you want to make the graphics live, you simply head up to your little pencil here, and it will toggle back and forth and make the editor live. So you press on it, and that's the live view of the graphics. You press and you're back into edit mode. So let's pull out. We're gonna then go down and add a duct. So we'll go to KitPix N4 SVG, and they have some ductwork. Drop down on the ductwork, and they should be a straight ductwork, but we can have module onto long, pull, drop. Okay, can move it around where we need. And this is our supply temp. We'll drop our supply temp there. Now we have our duct, and the next thing we'll do is our fan. So we'll take the supply fan status, bring, drop, and we're still here. Now it'll bring up the KitPix N4 SVG because we're still there. Then we just go to fans, drop down, and we want fan horizontal right, and press OK, and voila. You just pull our fan and drop it right into our ductwork right there. I do want to show you something that in the event that you decide to go into the palette and just go down to, let's find fans. The fan has to be linked to a point. So if you try just to pull the fan, say fan horizontal, and just try to pull blank, you'll see nothing. It's not linked to a point. So that's the reason why we pull the point and then link the fan and it. And what we'll do is we'll bring our start stop unit start stop. Bring that over, and this we'll just bring over as a bound label, and we'll edit it as we bring it in. Now double click on it, and we'll just change the background. We're going to do a bit of our own edit on this one. This you can also do. You don't have to use your KitPix. So here we go. That's our fan enabled. Now whenever you want to make your graphics live, once again you simply select voila. Now since our fan is enabled, you'll see the circulation. Now you can right click, set, and disable, and then there go, your fan is off. You right click, set, and enable, voila, your fan starts running again. You can go back to edit and begin to add all the necessary things to your graphics. You can add our return temp, stop your return temp in, and for this we'll go back to our palette and down to our and get the nice set point fill editor, and we'll add it over here somewhere. Actually our ductwork needs to change because this doesn't show how the return is coming in, but nevertheless we'll put it right here. Now it will display what you actually have, which is -13 because the sensor is not hooked up. And then you can make it live, and voila, we can see our action again, moving along. And you can scroll down and continue to add everything to your graphics in the same way using the graphics tools that is provided. I want to talk about one of the differences between J's and the N4J. That is the I/O. The AXJs had that were NDIO. They directly connected to your J's. Here's an AXJs. And of course, here's an I/O. And you would directly connect your I/O to Jace, and you can connect another similarly. And you mount it to the panel. Fairly simple. And from there you can discover the I/O. This is in the type. Now, but the things changed a bit. So the N4 Jace now has not NDIO and RIO, remote IOs. It's good in some sense. And as now you have network, you simply tie into your J wherever you wish to put your MST that IO. For example, you have your Jace on the first floor, and you have a AHU on the second floor. You can run an MSTP to the second floor, IO there for that AHU. So in this case, it's great. You don't have to put everything in the panel like the AX. So that's one of the benefits. You remote I/O wherever your MSTP wishes to be. And if you have more than one, you simply daisy chain. Benefit. The drawback? Years ago, we had controllers that were on a network. You had a main controller, and then the other controllers for the controllers. They didn't contain brain, they didn't contain any sort of actual functions. They were simply taking everything from the main. So in the network cut, you will have units just go right go down. And that was a big problem. So they began making more controllers, putting brain inside of smaller controllers. So even though you have a schedule telling the smaller controller what to do, if the schedule breaks, the small controllers still have a brain and your unit continues to run. It doesn't shut down. The IOs are similar. The brain, of course, is our Jace, the N4 Jace. The IOs, however many you may have on your system, they don't have a brain. They're simply IOs. So it is wise that you keep IO a bit closer to your Jace. Someone, as you know, how cuts your MSTP unit that IO is serving is going. The IO doesn't have any. It doesn't retain any memory. So that would be one of the drawbacks. Keep your IOs close so that the risk of cutting
STP and losing is less. IOs in the same panel in which case they'd have, or you could find the problem really quick because it has to be inside, if of course your IO stops doing what it should be doing. Aside from that, it's great to have the option of moving your IOs around with the new and 4. What you're looking at is a behind the line that runs from here to here. So the main order and the return is on this side. Then you have a bypass to kind of send the line. We have it on water and even sometimes on steam. Steam, it's to bypass a valve. Say for example your valve is defective and you know you need to bypass the steam around that valve, or you lose control of the valve. You have no control going to it, you can't open it. The guy may have a bypass to send the steam around the valve. So it's as it says, bypass. It actually bypasses, in this case it bypassed rather than going straight up, it goes right into the return, and thus you'll see the pressure balances out.
Let's talk about integration. Well, backnet integration using the N4 Jace 8000. First of all, let's log into our Jace. The platform, of course. Use the backnet device. And add it in the station. Ideal way to do it when commissioning the Jace is to make sure we can select the commissioning tool and go straight through the commissioning wizard. If it's already commissioned, uncheck what's not needed. And basically we're going to be adding what we do need. Don't change anything. May take some time depending on how much module is searching through. Okay. Once things open up, we can simply scroll down to the module, looking for the BACnet device that we need, or the BACnet module that we need. Few. Once we've added what we need, we can simply next. If you've already installed it, it'll tell you. If not, then you'll be installing for the first time. Now that we have the BACnet module, we can then go ahead to the station, add what we need, and begin to integrate and discover the BACnet device. Okay. Now let's open the station. And begin the station side of things. Let's talk about integration. Well, BACnet integration using the N4 Jace 8000. First of all, let's log into our Jace, the platform, of course. Use the BACnet device. And add it in the station. The ideal way to do it when commissioning the Jace is to make sure we've We can select the commissioning tool and go straight through the commissioning wizard. If it's already commissioned, uncheck what's not needed. And basically we're going to be adding what we do need. Don't change anything. May take some time depending on how much module is searching through. Okay. Once things open up, we can simply scroll down to the module, looking for the BACnet device that we need, or the BACnet module that we need. Few. Okay. Once we've added what we need, we can simply next. If you've already installed it, it'll tell you. If not, then you'll be installing for the first time. Now that we have the BACnet module, we can then go ahead to the station, add what we need, and begin to integrate and discover the BACnet device. Okay. Now let's open the station. And begin the station side of things. Now, let's talk about the 16 IO, 34 IO, at least one point. Sometimes we figure, right? We got a job. It's a quick, easy job, it's cheap. So we'll get the 16 IO. Now, the difference between, one of the difference between the 16 IO is that the 34 IO has in it the ability for you to power it. It has its own not so much power source, but you can add a 24 volt connection.
you can power it. If you purchase IO, you're going to have to purchase a power. Consider that when you're looking at a job. Okay, small job, I want to go cheap. You with the 16IO because you need a power. In addition, I mean, you'll be going somewhat cheaper, but with the 34 and also power 16IO. So just consider that as a point in mind when which two to go with, depending on how much point your system has. Now I want to talk about an error that is a certificate related error. Let's say you can log into your site. You know, you can, if need be, and enter your credentials and what you need to do. You can even open your platform, or you can even get remotely to your site. However, you get to your site, but you see nothing. You don't get any temperature sensors. You don't get anything at all. You're not getting any data. That could be a certificate issue. So just head into your server. Make sure the certificate for that particular station is approved. We'll do that and you'll see the difference. So platform, over to certificate, and we'll check. So the certificate for this particular site is not approved. So you're not able to communicate or send data. So we'll approve it. And just give it about a minute or two, and then your data will begin to load. Now these are some simple errors that occur that you can find in case you run into these troubles. Okay, and there you go. After a few minutes, your data will begin to populate and your system. Now that you have allowed the certificate, and it can pull the data from the JACE.
After connecting the physical IOs, the 16 or the 34, for our example we were using 34, to the JACE, then we need to go to our platform to add the necessary drivers. Log in, then we'll go to platform administration. And we'll go to commission. Uncheck all the top ones and just leave the bottom open. Configure additional platform daemon users. Next. And continue with let the drivers load and select the RDIO drivers. Scroll down. We're looking for the NRIO drivers. Okay. So we have 1, 2, and 3. We'll just check all once we find them. Select next and next, and then finish to allow them to be installed in our controller. Great. Once completed, now let's log into our station and configure the drivers and add our I/O. We'll head down to our palette. Down. It's okay. At our station, config drivers, and we will then add our NRIO network. No need to change the name. Okay. Then we can double click on our network. And now we can discover. So should be able to discover our device that is connected to our base. There we go. We double click. And here you go. We got 134 IO that's connected. Rename it. Okay. And now we can access the app.
What you see here is a pump, a hot water pump, and of course the motor driving the pump on top. One of the questions that comes up when servicing or when on the job with these pumps is flow. Which direction is flow? A lot of times you can see on the pumps themselves or on the devices on the pump here, direction of flow. So this is indicating flow. Here's another one, direction of flow. You can also look at the gauges. This gauge is showing about 130 pounds coming into the pump as the pump is pulling a suction on the water. You can tell the direction. So this is about 130, and the other gauge, if you take it close, about almost 170, also 50. So which way the flow if you don't have the indication telling you. And lastly, on the pumps themselves, if you look sensor. Now, if we have the BMS and BMS system, we can kind of see what the sensor is doing. AC tech, and we really don't have the sensors working right, we can use and see what's going on. If it's a 10, then relatively we should get something around that number as we put our meter across the sensor. Now here's a 10K sensor, and you can see from the meter 10.55, so it's about 10K. Depending on the room temperature, if it's colder or hotter, it will change because that's what it's. If the sensor is bad, sometimes we'll get a short. Dead short, two wires touching. And it's the same as anything, you'll get no ohm. That is you get an OL. Similar to your wires being simply open and you'd have to go around the world to touch each other, so you're not getting anything. It do go bad, but they have can be damaged. However, this way you can use your meter to get an idea. Good or roughly bad.
BACnet MSTP integration using Tritium N4. First step is to log into our platform of the station. We're in the platform. And we will need to add the modules to the station. So we go to Platform Administration. It should already be commissioned. Now it's just a matter of adding the necessary module for the back. Uncheck what's not needed. And just leave the bottom check, configure additional platform daemon. Next. We won't change license. Next. So it'll load all the modules and we select the ones needed. Once that's done, we could then go to the station. It may take some time. You scroll down to find the necessary modules that you need. And we're looking for the BACnet modules. Okay, so here we go. We just add all the ones that said BACnet. Then simply next, and it will add your module. Select finished, and now you have all the necessary modules added from the platform end. Okay, once completed, you can close out, and now it's time to go to the station. The next step in BACnet MSTP integration with N4 is to log into our station. This is BACnet. We've logged into the station. We'll drop down to config, drivers, and at this point there is no drivers, so we'll need to add the BACnet. Head down to your palette, search, and you will see the BACnet, Niagara BACnet driver. Press OK. So we're going to need to add the BACnet network. Just pull it and drop it on drivers. Do not rename it, leave it as is. Now we have BACnet network. Drop down. Your BACnet COM and drop down to network. You will notice you have an IP driver, but no MSTP. MSTP doesn't come automatic. That you have to add also. So you head back down to your palette and just select the network ports and drag up the MSTP and just drop it on network. Do not rename it. Okay. And now you have it. Double click on your MSTP port. You will need to give that network number and enable it. You also need to know what speed your BACnet network is on. If you set it up, you should know. Otherwise, you can just go through all the speeds and then see. I believe the one we have right now is 70. Up to your local device, you will see that it says a status of fault. Your local device needs to have an ID, something unique. And then save. BACnet network should give you the access to discover. I'll show you this. Just go back to your local device. Let's say you didn't do anything. You leave it as is. When you went to your BACnet network, you'll notice you wouldn't be able to discover. So if that's happening, then chances are you haven't enabled or provided a address to your local device. Once that's done, let's discover and see if we can catch it. Okay. And we are on, here we go. We have found our device. So we select our device, you can double click or select add. Once selected, you can just BACnet device, rename it. Okay. And now your device has been discovered. You can begin to get the points, necessary details. Those are the 2 steps that is necessary. BACnet MSTP integration using Tritium N4. First step is to log into our platform of the station. We're in the platform. Then we will need to add the modules to the station. So we go to Platform Administration. They should already be commissioned. Now it's just a matter of adding the necessary module for the BACnet. Uncheck what's not needed. And just leave the bottom check, configure additional platform daemon. Next. We won't change license. Next. So it'll load all the modules and we select the ones needed. Once that's done, we could then go to the station. It may take some time. Okay, once loaded, You scroll down to find the necessary modules that you need. And we're looking for the BACnet modules. Okay, so here we go. Just add all the ones. Then simply next, and it will add your module. Select finished, and now you have all the necessary modules added from the platform end. Okay, once completed, you can close out, and now it's time to go to the station. The next step in BACnet MSTP integration with N4 is to log into our station. This is BACnet. We've logged into the station. We'll drop down to config, drivers, and at this point there is no drivers, so we'll need to add the BACnet driver. Head down to your palette, search, and you will see the BACnet, Niagara BACnet driver. Press OK. Okay, so we're going to need to add the BACnet network. Just pull it and drop it on drivers. Do not rename it, leave it as is. Now we have BACnet network. Drop down. Your BACnet COM and drop down to network. You will notice you have an IP driver, but no MSTP. MSTP doesn't come automatic. That you have to add also. So you head back down to your palette and just select the network ports and drag up the MSTP and just drop it on network. Do not rename it. Okay. And now you have it. Double click on your MSTP port. You will need to give that network number and enable it. You also need to know what speed your BACnet network is on. If you set it up, you should know. Otherwise, you can just go through all the speeds and then see. I believe the one we have right now is 70. Up to your local device, you will see that it says a status of fault. Your local device needs to have an ID, something unique. And then save. BACnet network should give you the access to discover. I'll show you this. Just go back to your local device. Let's say you didn't do anything. You leave it as is. When you went to your BACnet network, you'll notice you wouldn't be able to discover. So if that's happening, then chances are you haven't enabled or provided a address to your local device. Once that's done, let's discover and see if we can catch on it. Okay. And we are on, here we go. We have found our device. So we select our device, you can double click or select add. Once selected, you can just magnet device, rename it. Okay. And now your device has been discovered. You can begin to get the points, necessary details. Those are the 2 steps that is necessary.
Rock your body to the beat and let the rhythm flow. Everything's gonna go and breathe. There's something about you. Put my finger on it. Rock your body to the side. You're free. Everything's gonna be alright if only let go. Finger on it. Girls on fire. I don't know what. Brown hair. Look at him, but I find myself confused. But then I know he's the one I choose. Sai di levar. Galamti. See, we roll with the punches so we can be. But you told me you couldn't as well, so. Looking for the soul in you. Just go through. It's the sound of the beat and let the rhythm flow. Everything's gonna be alright if only let go and breathe tonight. something about you. I put my finger on it. This time I see you. They're so in love with me. I wonder. He thinks of me, I think of him, and suddenly we're in love. Rock your body to the sound. Go right through your feet. Everything's gonna be alright if only let go and breathe. I just can't put my finger rock your body to the sound of the beat and let the rhythm. Everything's gonna be alright. Go and breathe tonight. I put my finger on it. Rock your body to the sound of the beat. And blow right through your feet. Everything's gonna be alright if only something about you. Finger on it. It goes on fire. I don't know. Those smooth eyes, long brown hair. And I know say to the calamity. Oh, punch us so we can be. couldn't as well. So I soul in you, and then through. Sound of a beat and let the rhythm. Everything's gonna be alright if only let go and breathe.
You watching look how
Let's set up the web access to RJ so that we can log in from the web. We'll go to our station. Onto our station, config, and services, and scroll down to web services. Select. Mine is already enabled, but a new setup JS will not be, so you simply enable it. You'll decide whether it's going to be HTTP or HTTPS. You can enable both, depending on what you need. Once enabled and you're ready to go, you'll select save, and then you can test. You should be able to log into your JS or your station via the web. So let's do that. We'll open the browser and check. There, you should be able to log right in. Now, if you're doing it for the first time, you may get the browser telling you that the certificate, there's an issue with it. It's fine. It's just proceed. Go ahead. It's because let's log into the platform. And then we'll head over to our platform administration. Then we'll head down to commission. We'll uncheck everything except configure additional platform daemon. Say next. Next. And we'll let it load the additional daemon so we can find. Then we'll scroll down. Make sure we install module. Okay, once completed, we'll close to our station. After we have added the module, git control module, we can go back to our station and log in and begin our programming. drivers, driver, and nice. Then we'll head down to the palette, open, and okay, so kit control library. It's okay. Okay, so we have our kit control. We will then go to our points, on our points, and to the top right hand corner, be able to go to our wire sheet. And on our wire sheet, we'll see all our points that we have added. Grab them, move them around wherever we like. Now, to begin programming, we can get what we need from our kit control. We'll just drop down the kit control palette, points, extension, triggers, etc. So we do want set point. So what we'll take is a numeric writable pull out, and this would be our, say, our this becomes our set point. We can write to it as we need, and we'll set a standard set point in there right now. Just head up to set, and for example, we'll put a 72. That's our return set point. So we'll continue. This would be our now. We have a lot of things in our kit control palette. When we scroll down, we have HVAC. In the event that we may need a loop, about our loop, and say this is our discharge here, temp. Oop. We have it. Nothing is connected. So what we do now begin programming, we can simply drag from the output of our sensors or our set points. You'll see on our set point here, it has the out, in. Now from the output side, you see your arrow changes. From the input side, you see your arrow go in that direction. Output goes in the other direction. You can simply click here, drag out, and drop on the device. Now, a loop, of course, will act several things: enable, control variables, set points, and so on. In this case, we'll click cancel, and then we'll take our discharge here temp, and we'll make this loop control our discharge here. That would be our set point, 55. And then we'll go to our discharge here temperature, which would be, it would be, yes, okay. So our supply temp is what we're looking for. So we'll grab our supply temp out, drop, and this would be our control variable. So now the loop is now looking at our supply temp, and the set point is where we set it. So similar to any other loop. Then we can go in, double click on our loop, and begin to configure it. You can add our proportional constant and enabled, as well as the loop action, direct or reverse acting. We can set all that up here internally. Once we're done, we simply put save. Another important thing about the loop, and we can just click back to head back to our wire sheet, is that the loop will need to be enabled. So we then, depending on how we're writing our program, we could write it in many ways. And let's move these over here to give ourselves some space. Okay, so now the loop also needs to be enabled. So we'll make an example. We'll take the set point that we have here for the discharge, and if we duplicate it, we'll make a return okay. And we'll head down to our kit control. Do not have any reading for the return here set point, but if we did, we'd use that. So for this example, just this example, we'll take from the supplier, and when that is greater than our set point, it should enable our loop to then, well, it should enable this and output to be true. And what we'll do is we'll just add a timer so it doesn't bounce back and forth. Add into our timer, make it about a minute. So it has to be greater than the set point for about a minute before it does anything. So we'll go in to our timer and out from our timer. Oops. Out from our timer, we then drop right on the bottom the white of our loop, give us the option and loop enable. So that way our discharge loop, and this would be, for this example, we'll have it be our, we'll rename it, this is going to be our discharge cooling loop. And go out to our cooling valve. So we'll just scroll down here, and we did not add a cooling valve, so why don't we go up and add our output to our cooling valve. Back over the points and VFD supply, we'll add our to our analog outputs, and we'll have our CC then. After adding our cooling valve, you can double click on points, it's still there, and back to the right, back to our wire sheet. Now our cooling valve should be, there it is, okay. So we'll take our cooling valve, and then the output of our loop will then land to the input, and we'll go to 16, we don't really need that on 10, to our cooling valve. Now we can, at this point, go back into our loop and make the output 10. basic loop. Five, we can check our loop. Then our loop goes to false, and we de-energize our cooling, our loop, and our valves. This way we can begin to write our sequences and our program utilizing this kit control as we now let's add a Jace to our supervisor station. First of all, we'll log into our super station. Then drop down to config drivers, and then Niagara Network. In Niagara Network, we'll add a new. We'll be adding a new Niagara Network here. That's okay. Okay. So first off, we'll need to know the name of our station. Has to be the exact name, and then all the other details. So let's go and log into our station that we're going to be adding, and then come back. Open the Jace station. Here is the name of the station that we're going to use. Now we'll go back to our Niagara Network, add new, and that station name will be new station. Has to be the exact name. 192.168.1.140, and our Fox port would be 49. Now, the username and password has to be the admin or a admin for a super password. Needs to do all the things that an admin needs to do. We need to enable this, and we press OK. So, what will happen? We'll see that it failed. We'll right click, and the action will go to ping. Try to connect, it won't connect. That's fine. Now need to go up to our platform, make some changes. In our platform, we'll go to certificate management, and then to allow host, and we'll see that it is not allowing this particular Jace. So we'll right click, approve, yes. Once it's in green, we can head back to our Niagara Network, and we'll see that it's in yellow state. Right click, ping, and now it tells us that the status it has acknowledged. So now we've added it. Now if we drop down on our Niagara Network, we'll see our new station. We can now discover all the points and all the data that's in the new station. And now we can begin to build out our graphics and our DMS properly. We've just added this new station, our BMS and our supervisory station. Let's commission the J's. First of all, we'll need to log into the platform with our basic IP address. One 192.168.1.140, one it's shipped with. This JS is already commissioned. However, we'll go through all the steps, commissioning step, except adding a station to the JS, which you can do while commissioning, but we will not. In addition to that, the JS, when new, comes with the basic password and username that has been changed. So, once you change your standard password, logged into the JS, then you simply go to platform administration. And once that loads, you head down to commissioning. It gives you the option to commission your JS. Once that pulls up, we get the basic checkpoint selection to set the enabled runtime profile and install the station from local computer. This we won't do now because later we'll have to create a station, and then once we create the station, we'll install it. You can always do that later. We won't do the language thing. It actually, if you'd like to upgrade the core software depending on what's on your computer, sure, why not? Won't worry about the syncing thing. Configure TCP/IP network. We'll go there too, because that you might want to set up to your specific network when you are commissioning the JS. And then configure paraphrase. We will check that. You will need to do that when you're commissioning JS. The JS need to have its own paraphrase protection password. And lastly, configure additional platform daemon. You may be using the JS for a specific thing, so you need to pull out those particular modules that you're going to need. So once these are checked, simply press next, and it walks you through. First of all, if you do not have a license, you can search for it on the server once your computer is logged in. If you purchase your JS properly, it should be on the server of Tritium, and then it'll find it, install it. Once you've installed it already, it says it's already there, so you don't need to change it. At this JS we won't, but in commissioning a JS you check here, so we can search it and find it, or if you had it on your computer, you'll be able to install it manually. Continue. And in the enable runtime profile, you can check what you need to be installed, so you'll be able to configure your JS accordingly. We have module jar having lightweight HTML, and we also have workbench or workbench applets, so this way we'll have those available and access to us. And generally those two I would recommend, depending. So select next. It will now search and load the modules that are available, so you can decide which you'll need. For example, drivers, LAN, backnet, and any necessary drivers you think you will need, and other modules. We will take a look at some of the basic modules. Scroll down and select what we think we need. or what we know we need for our project. Status. A lot that you may not need for a particular project. So you will need to know what this project is designed for. If you scroll down at this point, if you're using Modbus, you will have the drivers available here. We'll head down to the BACnet drivers. Here we go. And if you were using BACnet setup with this JSON, of course you would then add the necessary BACnet drivers and you'd be good to go. And so you would do for any module that you would be using. Once completed, you'll select next. It will then let you know if you need any software otherwise and upgraded things. I said okay, sure, why not? Then your TCP/IP configuration. Show you the standard. There is 2 ports. One comes configured and the other does not. If you think you need both enabled, you can. However, you simply change your IP address and then your gateway and add number 2 and then go ahead and select next. This one would leave this where it is, 192.168.1.140. Then you go next, it'll give you the option to change your paraphrase. We're changing because there's already one in there. But of course, if you were doing it from scratch, added our paraphrase, or in this case, we've changed it. It allows us to move on. We can then add user access to be able to add platform. Very important. This we already have 2, but if you didn't, you would simply add. And you select next. It will now add those modules that you have selected earlier and add all that is necessary. Simply select finish. It'll let you know and show you the process of what's going on. And once completed, it will give you the instruction and let you know that the device is rebooted. Once completed, it'll let you know that you are successfully completed the commission process, and it will reboot your Jace, and then you can log in. So we have successfully commissioned this Jace, and it's ready to use and to add a station to.
A bit about programming language and controllers. We have here a controller and a Delta controller. Both these controllers, the program is basic. What I mean by basic is if you're it's not something you do. I don't mean basic as in it's basic, the level possible. The program language is called. It's almost like telling the system in written words what you want to turn off AHU1 at 12 o'clock. So you write the program in and that's pretty much kind of what basic is. And both KMC and is a sort of a basic writing program language to set up. However, with the AX and N4J, the tritium type system, it's what you have is programmer, it's almost program friendly. You have a different kind of wire sheet for programming. You want a loop to control the heating. Or something like that. You select a block called blackout, and then what happens, you pull a link from the block to your valve that you want to control, then a link from that loop temperature sensor that's in the room. Now the loop is seeing the temperature and your valve. You can set point created where you pull a link from there to a set point. 72 degrees. So that's telling you 72 degrees is where I want things to be. So when it gets too cold, the loop then sends that signal to and opens it up. And when the temperature sensor sees it gets too warm, it says, okay, I'm too warm. Signal to the valve to close. Now that's what we do in any program, even in BASIC. However, in Tritium, you're not writing as you would. See, you simply pull a loop, and in that loop, everything is there. And simply all you're doing is just pulling a connection to your valve and pulling a connection to your sensor. So if you're not a programming person with that type of program programming knowledge and understanding, it's a bit easier to catch on with Tritium because it's almost like a graphic type of program for the most part. Now, as you get more detailed and snippets and things of that nature, you could do more detailed programming. However, in general, the wire sheet works that way. You pull a block, what you want it to do, you simply link it to where you want it to be. So the concept of it is easier for a person who's not a programming person to catch on and to do. What is connection? Let's say we have two devices. In this case, we have a RIO 34. We have port of the N4Js, and we've now chained or connected that to the RIO. That's a network of the JSON and the RIO, one device. However, let's say we have another RIO or another device that we'd like to network. And we'll simply, you can see the connection. We'll simply double the connection from and continue to the next device. Now from the next device, if there's other device, the same. And that would be a daisy chain connection. Now sometimes connection and someone comes along that you've got, and now someone adds a new device. It's close enough to this device, so they figure, well, they'll just tap in and just connect that device and puts it on the trunk. And they're done. Is that a daisy chain connection? Or if that's done, does your network daisy chain? No. Now it becomes a star connection. Very different thing. So you say to the person, look, that doesn't work like that. And what normally they say to you, well, what's the big deal? It's just a connection. Well, what's the big deal? Let's talk about big deal. If you take a daisy chain connection in the middle and make it into a star connection. Imagine yourself driving down a two-way, laws and rules, how fast you can, and everyone respects those laws and rules. Now someone comes along and jams another two-way highway directly into the highway you're going. An intersection in the middle of your two-way highway coming straight on, what happens? Now you have now you have traffic jam. Now you have accidents. The whole traffic changed. Everything is different. So that's exactly what happens when you the flow of traffic going slam right into the middle, boom. Car connection. You've now entirely different laws apply. We operate under the law. The internet law for transmitting data. Transmission protocol. And under those laws, we operate with MSTP, transmitting our data. In those laws, the different types of communication. One which is daisy chain, another, both of which have different laws and how data can go and how they should travel. We have to respect those laws. We respect the laws driving traffic in our country. You can't just decide how you're going to drive on a highway in a particular country. No, the government's and the rules, and you must respect those. Same with a daisy chain connection. These set the laws and the rules for daisy chain connection. We need to follow that. And we can't just slam something into the middle and consider it a daisy chain. Now it's a star connection, something totally different. One of the good things with the daisy chain is if the line breaks, to my IO, someone inadvertently cut the next wire that goes to the other device. All the devices downstream, except for the IO, will be missing. It's a bit easier to find the problem with a daisy chain connection, because now we can from the living IO the IO that's online to where everything else has gone down. Normally our VAB boxes are in daisy chain connection. Set them up and they come right back to our panel, and of course IOs
Logging into our station, drop down to config, and drop down to drivers. At this point we don't have any drivers, so we'll need to add. Palette should be somewhere down here. You can simply then you're going to need the BACnet network. Once you have it, we're going to set it up. However, being that we're doing BACnet MSTP, when you first install it, it will have the availability for BACnet IP. However, you need to add an MSTP port. It lands with an IP port, but not an MSTP port. So you'll simply drop this on network. Do not relabel it. Label it MSTP port. Great. Almost set to go. You have to make it active. You'll need to give this a network number, something high and different from everything else. If you don't know the speed, you can just go to random test. Rate. And we'll head up to number, nothing foreign and different. Cover. It has a talk on one of these BACnet speed. So if we don't know, we'll simply go through it. But if we set the network previously, we should know what it is. Head back down. We'll try 34.8. And give it a shot. If not, we'll head back down. Seven six. Give it a shot. 26.8. Give it a shot. Okay, what do you know? There we go. Our device is here, ready to go. Device ID, and now we simply need to add it. And once we've added it, then we'll be able to see all the points necessary. We can rename it. After connecting the physical IOs, the 16 or the 34, for our example we were using 34, to the Jace, then we need to go to our platform to add the necessary drivers. Log in, then we'll go to platform administration. And we'll go to commission. Uncheck all the top ones and just leave the bottom open. Configure additional platform daemon users. Next. And continue with let the drivers load and select the RDIO drivers. Scroll down. We're looking for the NRIO drivers. Okay. So we have 1, 2, and 3. We'll just check all. Once we find them, select next, and next, and then finish to allow them to be installed in our controller. Great. Once completed, let's configure our alarm extension. We'll log into our station. And to configure drivers, IO, and then our points. We will then go down to our palette, and if alarm is not already selected, we can just open our palette. Once selected, we can head to extension. We're going to put the alarm extension on our temperature, our supply temperature. We will use this as a test. So you simply take the out of range alarm extension and drag it and drop it on your sensor. Then you will see it underneath, or if you drop down in your sensor, you will see out of range alarm. You can then double click and begin to configure the sensor. So let's set a high limit of, say, 70. Then enable the high limit, save, and then check back on our points. Now, our temperature currently is, it's telling us that we have an alarm. Red, because our alarm is at 70, so we're above. If we head back now and change our alarm to, say, 75, our high limit, check the points, alarm is gone, but it's telling us that it's not acknowledged. I also want to show you the alarm. Put it back to 70. Show up as well in your wire sheet. Scroll up right under your station, you'll see the alarm here. Double click. This opens up the alarm section to let you see the alarms that have passed, and you did not acknowledge it, and it tells you it's still there. And the current one is there with the message temp is high. So to clear the alarm, you can simply select it, clear selected record, run maintenance, yes. Okay, now you're left with the one that's currently in alarm. Of course, let's get rid of this and then clear it also. So we'll head back down to our section, which is the set point, and of course the alarm extension, and we'll put 5 and select our points. The alarm is gone, but it's telling us that it's unacknowledged. So we will head up back to our alarm, and then there it is. We select it. Yes. Okay. Drop the alarm and remove it, and then remove it from our panel. Now let's create an alarm console. We'll log into our station. This way we can collect all our alarms and reset as we see. And click on alarm services. You have down your palette and go to recipient, and we'll select a console recipient, drag that over, default alarm class out to your route alarms. Then when we double click on our console, we'll see our alarms here. So let's do a test. Let's scroll down to back up on services, drivers, IO, points, and extension down to our point. Now supplier temp, we have our alarm set up here. So scroll down and let's put this into alarm. Let's set so we'll put it into alarm, save, and go to your points. Okay, we'll see that's in alarm console. Services, alarm services, double click. Now click console. You get your alarm, the annoying sound. You can click silence, and once the alarm is gone, we'll head back down to our temperature set point, alarm, and let's take it out of alarm. We'll head back up to our console. And alarm service. Now let's take a look at this alarm. You double click inside, you will see the priority settings, 25 being the highest, 1 being the lowest, of course. So back up a bit and we will head to our alarm and we'll add an alarm class. And this one we'll call high priority. Let's set let's set let's set and that you want to have some high priority alarm, you head down to this drivers and drag that over IO. That is how you can then in your alarm extension scroll down and you would see the class here. You can change it from the default class to making a high priority. So now this alarm becomes a high priority when it goes in alarm. Now we will set it. Notice that the priority of the alarm is 1, as opposed to before it was 255 because we came from the basic priority. This way you can separate or segregate your alarms, high priority or low priority, as you see the need to do so, based on the alarm, of course. If we revert back, enable the high limit. We'll take it out of alarm. Drag that over. Now let's create an alarm console. we'll log into our station just so we can collect all our alarms and reset as we see. And click on alarm services. You have where down to your palette and go to recipient, and we'll select a console recipient, drag that over, default alarm class out to your route alarms. Then when we double click on our console, we'll see our alarms here. So let's do a test. Let's scroll down to back up on services, drivers, IO, points, and extension down to our point. Now supplier temp, we have our alarm set up here. So scroll down and let's put this into alarm. So we'll put it into alarm, save, and go to your points. Okay, we'll see that's in alarm. Console. Services, alarm services, double click. Now click console. You get your alarm with the annoying sound. You can click silence, and once the alarm is gone, we'll head back down to our set point, alarm, and let's take it out of alarm. We'll head back up to our console and alarm service. Now let's take a look at this alarm. If you double click inside, you will see the priority settings, 25 being the highest, 1 being the lowest, of course. So back up a bit and we will head to our alarm and we'll add an alarm class. And this one we'll call high priority. In the alarm priority, you will see the numbers 255, and of course we have a selection of 1 here, 1 being the highest and 255 being the lowest priority. And that you want to have some high priority alarm, you head down to this drivers and drag that over. IO. Here is how you can then, in your alarm extension, scroll down and you would see the class here. You can change it from the default class to making a high priority. So now this alarm becomes a high priority. when it goes in alarm. Now we will